Oh, you're fine. Okay, so it's technically. Do you know how like DNA synthesis? Like Ben explained this a little bit, but how DNA synthesis works? Where this right here is a code right here that this telomerase, this enzyme has, and technically what it can do is it can take this code and it can repair and add it on to the deteriorating telomere. So it adds its code on, and then the DNA is able to replicate with a longer code. So it's able to, like, this attaches like extra to the end of the DNA strand, and therefore repairs the ends of the chromosome. And
how does it get from there to there?
From where to where?
From there to there. No. Telomerase or whatever.
Telomerase?
Yeah.
Well, because it's a protein that is in cells. Okay. It's an enzyme. Like I can't remember. It's like what makes DNA.
Yeah.
And this is actually really interesting. Telomere is only active in reproductive cells. Telomerase, and then in all others, and there are a lot of other cells that it's found in. The cells of your skin age, when you get like wrinkles but it's not active. So it's called depressed. It's not active, but it's still there. And there's an interesting fact that those who exercise regularly and eat healthily actually have longer telomerase at the end of their chromosomes than those who don't. And people that say that they're more stressed, there's a test that measures how long the telomerase are, and people that view themselves as more stressed have shorter telomerase. And
so what if you were really stressed and then you also worked out a lot?
I think that it would compensate itself. Telomeres are thought to be a key factor in the maintenance of human cancers. And what that means is that in a lot of cancers, there are active telomerase, which means that cells that should be dying are actually repairing themselves and making themselves immortal. So cancer metastasizes because cells like proliferate more and more and more, and at a rate that is like unhealthy, and that causes tumors.
So this is like, because it's not fully proved, this is like the theory of cancer, maybe?
Well, this is one of the reasons that cancers are so difficult. Well, tumorous cancers, a lot of cancers are so difficult to kill, to treat. Yeah, because the cells just keep reproducing, and telomerase is one of the reasons for that. There's research that there may be a drug that suppresses telomerase that can combat a wide array of cancers. May also play a role in the aging of human cells. So, in theory, we could introduce a drug into the system that represses telomerase, making the cancer cells of a tumor just literally stop reproducing, dry up, and die. And then, theoretically, in a petri dish, you could modify it so that telomerase is active in cells that are dying that are important. So skin cells, liver cells, anything that deteriorates with age could possibly reverse the aging process if the telomerase is activated in aging cells or in cells that have reached their reproductive limit. And that raises another question, like, are we playing God? Like, are we, like, who are we to kind of pick and choose? Like, it could potentially reverse aging. Like, that's crazy. People could live for, like, tumors that use this are virtually kind of immortal. Immortal. They're immortal, technically. And you have to inject a lot of toxic chemicals into the body to kill the cancer cells. Right. And that also kills positive cells that are doing the right thing.
So, like, if you could, like, harness, like, that single
theoretically
piece. Yeah, that's pretty nuts.
It's crazy. It's insane. I'm thinking if there's anything else that I need to say.
So are they doing, like, tests for this? Or
yeah, there's ongoing research, and right now, They don't know if, like, if they introduced a drug that suppressed telomerase into the system, if it would be harmful, like more harmful to other parts of like the body or other parts of the body that use telomerase in a positive way. But it's a fairly recent discovery, and so there's like ongoing research on that, and they haven't done many human tests. They did an animal test where in rats they made all of the telomerase inactive in the cells, and the rats aged incredibly quickly. And then they like fed the rats or injected the rats with something that activated the telomerase again, and the rats they like regained healthy reproductive systems. Their coats were shinier, and they showed signs of like reversing the aging process. So that is there's a lot of like speculation about how we could reverse the aging process and possibly cause human cells to become immortal, the positive ones, not the negative ones, and target the negative cells in order to kill them. And that's kind of, I mean, I don't know, that's like, test tube babies kind of thing, but it could potentially have some really incredible positive